Section 6.5, it's about your favorite problems, application problems, or commonly known as what? Board problems, correct? So don't panic. I will go over a few examples and hopefully that will get you going. The first kind is called work, as in K, problems. Basically, the formula is rate of work times time worked is equal to part of the work completed. But in order to what? Find part of the work completed. So what you do is you find the part of the work done by the first person plus part of the work done by the second person equals one whole job. In other words, if I do 1/3 of a job and you do the remaining 2/3, when we are done with the job, we have done 100% of the job, which is what? One whole job. Yes? So that's where one is coming from. So what does that mean? First of all, what is the rate of work? Well, if someone can do a job in 5 hours, his or her rate is 1/5 of the work per hour. In other words, if this person can complete the job in 5 hours, in 1 hour, he or she has completed what? 1/5 of the job. So that's what they mean by rate of a person, because the rate of the work by a person times the time worked equals part of the work completed by that person. So let's see an example. Maybe that will clear this. If Mary can paint a room by herself in 6 hours, and Joe can paint the same room by himself in 4 hours, how long would it take them working together to paint the same room? So what do? You let X be what? Time, what? Working for them working together. So X is the time takes for them to work together and finish the job. Mary can do the job in 6 hours, so her rate is 1/6. In other words, in 1 hour, she can do 1/6 of the job. That's what they mean by rate. But remember, the formula says rate of the work times time worked equals part of the work completed by that person. So in this case, we don't know how long it took them to finish the job, so that's X. So we multiply these two guys, that's 1/6 times X, which is the same as X/6. Remember, these are identical statements. It took Joe 4 hours. His rate is 1/4. So that means in 1 hour, he has completed 1/4 of the job. Then we multiply by the amount of time worked, which is X, that's together. 1/4 times X gives you what? 1/4 of X, that would be 1/4 times X. But that's exactly the same as saying what? X/4. So X is the number of hours for Mary and Joe to what? To paint the room working what? Together. Remember, the formula says part of the job done by the first person plus part of the job done by the second person. You add these two parts, you get 100% of the job, which is one whole job. In other words, we take X/6 plus X/4. We add it always equal to 1. So that means one whole job, correct? Which means 100% of the job completed. Okay? So give a denominator of 1 to 1. Find the lowest common denominator of what? Of 6 and 4 and 1, which happens to be 12. Multiply both sides of the equation by 12. Remove the parentheses. You get what? 2x plus 3x equals 12. So that's 5x equals 12. So x equals 12/5 hours. So it took Mary and Joe 12 over 5 hours to complete the job, which that's the same as 2 hours and 2/5 of an hour. If you divide 5 into 2, you get 0.4. But if you multiply, let's say 0.4 by 60 minutes, because remember 1 hour is what? 60 minutes, correct? You get 24 minutes. So the job was completed by both of them in what? In 2 hours and what? 24 minutes. So that's what 2/5 of an hour is 24 minutes. The next problem is number problems. The problem is one number is twice another number. The sum of the reciprocals. Reciprocal means if you flip the numbers and add them up, the sum is 3 over 4. Find the numbers. So we're going to say let x be the first number. The second number is twice. That means 2x. So the first number is x. The second number is 2x because it says one number is twice the another one. It says the sum means add. Reciprocals means what? Flip the numbers. So if you flip what? X over 1, you get 1 over x. If you flip 2x over 1, you get 1 over 2x. So these are called reciprocal of those two numbers, which one happens to be twice of the other guy. The sum, that means if you add these guys up, the answer should what? Be 3 over 4. And that's how I got my equation. This is so-called my algebraic equation, correct? So 1 over x plus 1 over 2x equals 3 over 4. The sum of the reciprocal, not themselves, but the flip version of these two numbers adds up to 3 over 4. Find the numbers. So now you find the lowest common denominator of x and 2x and 4, which is what? 4x. You multiply both sides of this equation by 4x. Then you distribute what? The LCD to remove the what? Parentheses. On this side, you get 4 plus 2. On that side, the 4's cancel, you get 3x. 6 is equal to 3x. Divide both sides by 3. X is equal to 2. So one of the numbers was 2. The other one was, excuse me, twice of the first one. Twice of 2 is 4. Final answer. The numbers are 2 and 4. And that makes sense. Notice one is twice of the other one. And if you flip these guys out and get what? 1/2 plus 1/4. The idea is, does this add up to 3/4? You know, this is just to check and see if we got the right answer. LCD is what? 4. Multiply top and bottom of this fraction by 2. And lo and behold, you get 3 over 4 is equal to what? 3 over 4 checks. So those magic numbers were 2 and 4, such that one is twice of the other one. And if you flip them, add them, you get what? 3 over 4. The next set of problems are called motion problems. Okay, so let's see. Motion problems, if you recall, the formula is rate times time equals distance. So r is a rate, which is like the same as the speed. T is the time, and d is what? The distance. Okay. Now, here's the problem. A train and a car, what? And a car, what? Leave from Pasadena railroad station at the same time. So read the problem carefully. It says at the same time, headed for State Fair in in Sacramento. The car averages 50 miles an hour, the train averages 70 miles an hour. If the train arrives at the fair 2 hours ahead of the car, so remember the train already got to Sacramento 2 hours ahead of the what? Car. Find the distance from the railroad station in Pasadena to State Fair in Sacramento. What would be the distance? So I'm gonna say let x be the train's time, but the car's time will be x plus 2. Why? Because remember, train was ahead of what? The car by 2 hours. So for the car to, so the car was on the road 2 hours longer, what, than the train. So if it took X many hours for the train to go from Pasadena to Sacramento, it took what, X plus 2 hours for the car to get to the same destination. In other words, if it took 6 hours for what train to get there, it took what 8 hours for the car to get there. Why? Because the train got there what 2 hours ahead of the car. Do you see it? So we have to add 2 hours to the car's time. The average of the what car speed was 50. Notice train is going faster than the car. Obviously, train is going to get there sooner than car. So we decided what the times for car is x plus 2, for train is x. You multiply rate by time, you get distance. Here you multiply 50 by x plus 2, you get 50 times x plus 2. Here you multiply 70 by x, you get 70x. Now I'm going to set these distances equal. Why? Because regardless of whether you travel by the car or by the train, you travel what? You have to cover the same mileages. In other words, it doesn't matter how you got there, the distance never changes. So what that amounts to is we have to have what? Same what? Distances. Distances. Correct? So I set what? This distance equal to that distance. Then I kind of solved what? For x. So what I did was I came up with, let's see now, that would be like 50x plus 100 is equal to 70x. So this would be like what? 20x is equal to 100. Is that right? X is equal to, let's say, what? 5 hours. But keep in mind that did not answer the question because remember we decided X is the what? The time, not what? The distance. So now to find the distance, you have to go either here or here, replace the x's with 5 hours, and if you go here, 70 times 5 is 350 hour. This is 350 miles, correct? But if you replace the x here with 5, which is 50 times what? 5 plus 2, that also should give you the same mileage, which is what? 350 miles. So as you can tell, the distances remain the same. In other words, what difference does it make whether you drove your car or you took the train? The distance doesn't change. So that just means when you once you get the what the time, how long it took. By the way, that was the time for train, so that it took train 5 hours, but it took what the car 7 hours. Okay, but you know it doesn't matter whether you what take the x equals 5 and substitute here or here. Notice you're getting the same mileage, which is 300 what? 50 miles. Our last example is this guy, which is about what? In a 30-mile sailboat race. So remember the distance was 30 miles. The winning boat finishes 10 minutes ahead of the second place boat. So this guy got there 10 minutes earlier than the second, so this is off. Okay, if the winning boat's averages what? Oh, let's see now. um, let's see. Okay, so if the winning boat's average speed was 2 miles per hour faster than the second place boat, find the average speed of each boat. So once again, there was a 30-mile sailboat race. The winning boat was what? Finishes 10 minutes ahead of the second what? Boat. If the winning boat's average speed was 2 miles per hour faster than the second boat, find the average of each boat. All right, so how would you do this problem? The way I set it up, I said let x be the second place's boat's speed. Okay, why? Because it says the winning boat average speed was 2 miles faster than what? Second place boat. So if this is so many miles per hour for second place boat, this guy was 2 miles per hour faster, so I have to add 2 miles for this guy to get what? The speed for the first place boat. Okay. Remember, as far as the distance, they had to travel the same amount of distance. So distances were the same because this was a what? A 30-mile sailboat race. So we know the distance. What we don't know, the time and the speed in this problem. Now, if you remember, r times t is equal to distance. So if you divide both sides by speed, time is equal to what? Distance divided by speed. So that's how you find time. You take distance and divide it by speed. Notice in this chart, I know the speeds. Remember, these are so many miles per hour. And this is the distance, which is so many miles. And these are like hours. So what I do, I take the distance divided by speed. That would give me the amount of time which took what? First place to get to the end of the race. 30 divided by x is 30 over x. Okay. But now somehow I have to incorporate this piece of information. The winning boat finishes 10 minutes ahead of the second place boat. It's kind of like that train and car problem which we just did in previous example. So what you have to do is first, because this is 10 minutes and the speed is so many miles per hour, so first thing first, we need to convert the minutes into hour first, because you can't have minutes and hours, in the same problem. Either you have to work with minutes or hours. So you need a conversion of formula, conversion. So 10 minutes, if you divide it by 60, because 1 hour is 60 minutes. So divide 10 by 60, that would give you 1/6 of an hour. So what we're saying is to say 10 minutes, that's exactly the same as saying 1/6 of an hour. Okay? Just like the train problem and the train and car problem, you add that 10 minutes to what? To the slower boat in this case. And remember in the previous example, if you remember, we had, where did it go? Right here. So, right, right. Um, so, so remember, we added what? The 2 hours to the slower vehicle, which was what? Car. Do you see? So same thing goes here. So we always add what? the amount of time which one boat or one car or one train or one plane is ahead of the other one to the slower uh, to the slower one. In this case, we add that 10 minutes, which is 1 over 6 of an hour, to the slower boat and set it equal to what? To the time of the faster. So this is the time of the slower boat plus that what? 10 minutes equals this what? Time of the first place boat. Anyway, so what you get is 30 over x plus 1 over 6 equals 30 over x plus 2. So the idea is what? Find x. What was x? X was the what? Speed of the second place boat. Is that right? So second place boat, right? So what you do is find the lowest common denominator of x and 6 and x plus 2, which happens to be x, 6x times x plus 2. Multiply both sides of this equation by this LCD, remove the parentheses, okay, and lo and behold, you get this. Remove these parentheses, okay. At the end of the day, when you combine the like terms and put the equation in the standard form, because it's a second degree polynomial, you get this. If you factor x squared plus 2x plus 360, that ends up being equal to x plus 20 times x minus 18. You set each of these guys equal to 0 and solve for x, just like what we did in section 5.8. This guy gives you x equals negative 20 miles per hour. That doesn't make sense because you can't have a negative speed, but this guy gives you what? X is equal to 18 miles per hour, and that makes more sense. Remember, the speed of the first place was 2 miles faster, so what you do, you add 2 miles to 18, so this would be the speed of the faster boat. So the conclusion of this problem is the speed of the first place boat is 20 miles per hour. The speed of the second place boat is 18 miles an hour. Thank you.